Good evening, girls. In this video, we're going to discuss about mathematical analysis of recursive algorithms. Okay, so you know the procedure, right? General plan is to find out the basic operation, and based on that basic operation, we're going to find out the time efficiency of the algorithm. This the same general plan. So now, the first problem under mathematical analysis of recursive algorithm is to find out factorial of a number. Okay, so you know the procedure to find out factorial of a number by using recursive functions. No, say for example, if we want to find out factorial of number 4, then it can be written as 4 into 4 minus 1 factorial. Okay, and 4 minus 1 factorial, it is simply 3 factorial, and this 3 factorial can be written as 3 into 3 minus 1 factorial. And in the same way, this 2 factorial can be written as 2 into 2 minus 1 factorial, and 1 factorial can be written as 1 into 1 minus 1, that is 0 factorial. So these cases we call it as the general cases, and this one is the base case we call. In terms of recursive algorithm, the algorithm is divided into two types of cases. One is the recursive case, another one is the base case. Recursive is nothing but general case. Okay, how do you arrive at the solution? See, recursive type of function, it is nothing but a function which calls itself, no, every time, which will be calling itself. When it has to be stopped, when those recursive functions has to be stopped, when it arrives at the base condition. So here in this case, the base condition is whenever we reach the 0 factorial, it should be equated to 1 and stop the iteration. That's what it says. Okay, so these we call it as the general cases, and this one is the base case we have. Okay, so now how can we write the function for this? See, like this we can write in general. So 4 into 4 minus 1 factorial can be written as n into f of n minus 1. So n value should be greater than 0, then only we can perform this way, this condition. Okay, so when n is 4, when n is 3, when n is 1, we can perform this condition. Okay, so whenever n value is equal to 1, when n value reaches 0, then it should be equated to 1, which means that 0 factorial is equal to 1. If it is other than 0 factorial, then we are supposed to perform this general operation. That's what it says. Now, using these two conditions, whenever n value is greater than 0, we are supposed to perform this n into f of n minus 1. And if n value is exactly 0, then we should be returning only value 1 to the main function. Okay, so using these two conditions, so now we can write this way. Okay, using these two we can write like this, that is this, f of n is equal to f of n minus 1 into n. Okay, so that can be converted like this, m of n, f of n, instead of f of n, I am using m of n is equal to m of n minus 1. Okay, to compute f of n minus 1, I have written down as m of n minus 1 plus 1 specifies that this n minus 1 is going to multiply with n only one time. That's what it says. Okay, so we should compute m of n minus 1 factorials plus 1 specifies that f of n minus 1 will be multiplied only once with n. That's why we have put 1 here. Okay, so to multiply f of n by f of n minus 1 by n, we require only one multiplication. That's what it says. Okay, so to multiply this with this, we have only one multiplication operation. Okay, we should perform only one time. That's what it says. N is going to be multiplied with f of n minus 1 only for one time. Okay, apart from that, we should perform m of n minus 1. So this will be your entire equation now. M of n is equal to m of n minus 1 plus 1. Okay, so now when n is 0, no multiplication is performed, right? So what is 0 factorial? 0 factorial is directly equated to 1. We're not going to multiply anything. Whenever value of n is 0, we will not be multiplying anything. That's why when n is 0, no multiplication is possible. Okay, so there are two conditions. This is for the general case. If the value of n is this one. If the value of n is greater than 0, then we will be performing m of n minus 1 plus 1. That is 4 factorial into 4 minus 1 factorial. If, say for example, that's what we perform here. 1 for n minus 1 will be multiplied with n only one time. That's why we have put 1 here. Okay. What is m of 0? When n value is 0, we perform 0 multiplication. Okay. So n factorial is 1. But here what we are saying, when n in value reaches 0, we will not be performing any multiplication. 0 is nothing but we will not be performing any multiplication. We are not supposed to write the value of 0 factorial here. We should mention, are we going to perform multiplication when n is 0 or not? Okay, it is not the value of 0 factorial. Okay, so when 0 factorial, we not going to multiply anything. That's what it says. Okay, so now we are supposed to find out the efficiency, average time efficiency of this algorithm. For that, we have so many methods available, but here in this case we use one major important method called as backward substitution method. Okay, so how we can solve that? We should write down the operation m of n minus 1 plus 1 operation. Now wherever we find m of n minus 1, it should be replaced with like this. M of n minus 1 should be replaced with m of n minus 2 plus 1. And this m of n minus 2 should be replaced with m of n minus 3 plus 1. And this m of n minus 3 should be replaced with m of n minus 4 plus 1. See, look at this. So m of n minus 1 should be replaced with what? N minus 1 should be replaced with m of n minus 2 plus 1. That's what we have done here. M of n minus 2 plus 1. This entire thing should be replaced with m of n minus 2 plus 1. Okay, you should retain this as it is. So now the finally it will be equated to m of n minus 2. So you will be adding these two, it is 2. Okay, so whenever we find m of n minus 2, it should be replaced with m of n minus 3 plus 1. This entire thing should be replaced with m of n minus 3 plus 1. Okay, this entire thing should be replaced with m of n minus 1 plus 1, and it will be retaining the previous value. Okay, so we are getting in this pattern every time. Okay, so every time when we perform this, we are getting in this pattern m of n minus 3 plus 3. So in general, can I write it as m of n minus I? It is not 1, it is I. Can I write in this format? M of n minus I plus I, because every time we are getting in this pattern. So I made it as generalized version. So now here what we should do is, see, look at this. See here. Yeah. So we are getting in this in that pattern, no? That is m of n minus I plus I. So we should, when we have this general equation, when we get this general equation, you should go and look at the base case of the algorithm. What is the base case of the algorithm here? So base case of the algorithm says that m of n is equal to 0. Okay, so you should find out the base case of the algorithm. See here, you can look at the base case of the algorithm. This is the base case of the algorithm, this one. See, m of 0 is equal to 0 is the base case, this one. This is the base case of the algorithm. Okay, m of 0 is equal to 0. You should remember this now. So now what we should do is, by using that base case value, we have this generalized equation, no? So this should be substituted with the base case value, which means that, what is the base case value? It is 0, which means that n minus I, like this, it should be substituted to the base case value. Okay, so now after that we will be finding out value of I. So n minus I is equal to 0. I is equal to n, which means that minus I is equal to minus n, minus minus gets cancelled, so finally I is equal to n. Okay, I is equal to n. So now wherever we have value of I, replace it with the value of n. Okay, so n minus n, replace I with n. So what is n minus n? It is 0 plus n. What is m of 0? Go to the base case again. So go to the base case again. What is m of 0? M of 0 is 0. So put that value here. So 0 plus n is equal to n. Okay. So finally, what is the average time complexity it requires? N is the time.